Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're gonna take a look at supercapacitors. So let's dive right into it. So capacitor, you have to understand before you understand supercapacitor, is just a simple power component. Basically in your circuits it generally stores power. Sometimes DC power, sometimes AC power, sometimes for a small while, sometimes for a long while. So it is a power component, and there are multiple types of it obviously, and these are generally the symbols that are used to show them. Now on top of that, they are what we call direct energy storage system. Now what does that direct means is simply when electrical energy comes into the system, as in the capacitor, it stores it as is. Basically there is no what happens in your battery where energy is converted into chemical system. When that chemical energy is reconverted, then you get the electricity out. That does not happen in a capacitor. To understand this much more clearly, think of it this way: capacitor is the capacitance of a place. Now you can create a capacitor by yourself. All you need is a two metal plate separated by air gap. So that's what simple about capacitor. That inherently that's all it is. Now of course there is a lot of chemistry going into it, but chemistry is not changing like a battery. So that's what it is. It's a simple power device which sometimes you can see some things like this big capacitors. These are generally done for what we call power factor correction capacitors. Generally you can find things like that in electrical substation, to smooth out the power grid. Many of these are available in either your motors to reduce its power factor. Almost 100% of electronics uses this. Only some electronics exists that does not use capacitor. So the idea of supercapacitor is kind of a misnomer. Like supercapacitor is basically more advanced design. It generally has more surface area, translating into more capacity. Now the reason why people call it supercapacitor is that all the electrical circuitry was built for capacitors. So if you introduce something that is new and you still call it capacitor, the problem is people might interchange them, and their behavior pattern is far enough that this should not happen. To make everybody's life simple, they simply say capacitor and supercapacitor. That's why you can still buy capacitor. It's just that electrical circuits have different needs. For that reason they're like, okay, we're gonna classify it differently so you don't mix them up. So you have to understand this. Like capacitor also stores energy. This on the other hand stores much more of it. Now batteries, as many of you are familiar with, is generally have what we call cycles, as in how many time it can go from charging to discharging, charging to discharging. Now every time you are charging it, you are giving it one cycle. The moment you remove it, it's discharging. It does not matter whether you have a load connected to it or not. So when you do things like that, you will find out lead acid battery generally has 1000 cycles, as in 3 years of lifespan. If you are doing one cycle a day, you can go 3 to 4 or 5. If the plate is super thick, you can get a much longer lifespan. And when you're talking about lithium ion, it generally has 5000 to 10,000 cycles. That is on the ultra upper end. That's not normal is 3000, but 5 to 10,000 is generally trying to be utilized in your car batteries. That's why your car battery does not die in next year same way your mobile phone dies. But these puppies, they have cycle lives of millions, multiple millions. So do not worry about them running out of cycles. Basically, even if you are cycling them multiple times per second, you will still need 2 to 3 years to completely waste their cycles. So they are very long lasting. Now many of you are familiar with lead acid batteries that are generally used in your car. Now if you know how to charge those, you will realize that it takes long time to charge. Like it could take upwards of 2 to 3 hours to charge it from 0 to 100. However, while discharging, that charging cycle is generally denoted on your battery with character C. Discharging a battery is generally very powerful, as in you can discharge your car battery upwards of 800 amps. That's how lead acid battery generally turns your basically self starter. 800 amps is a no joke. Like inherently your battery only has 50-60 amps of capacity. So to discharge 800 amps, that you can understand, like if it can absorb even 400 amps, it should be able to charge in few minutes. But that does not happen because C and D is not proportional. This happens with the lithium ion also. In case of lithium ion, the D is not very big. However, the C is better, but still the gap is still there. Your C is generally 2 or 3 times smaller than the D. So problem becomes like you can discharge, you can drain a lot of power from your battery system, but you can't charge it as quickly as possible. So this translates into you having a real world electric car that if you drive at full force, like and you will turn out that you can drain the battery from 100% to 0% in upwards of, let's say, 2 hours. But to charge it from normal system, it will take many hours. Even with 3-phase system with active cooling system and all that, it still takes half an hour to charge. So the C and D is not balanced. In capacitor is exactly balanced, perfectly balanced. So that allows it, that simply means if you have supercapacitor and if you have the energy, you can charge it in an instant. Now of course not mathematically instant, I'm just talking like less than a second, less than a minute, or things of that nature. Now supercapacitor generally are also becoming much more talked about subject. So there is some classification that there is double layer, there is pseudo capacitor, because capacitor does come with some consequence that people are trying to merge capacitor with batteries. So that's why you have pseudo capacitors. So generally supercapacitors are kind of awesome things, but be mindful they are very low voltage. As many of you are familiar with the cell architecture used in almost every battery, generally each cell has a voltage. So let's say your lead acid could have voltage of 1 volt to 1.8 volt, and your nickel hydride would have 1.5 to 2, and your lithium ion could have upwards of 3 volt to 4.5 volts. So when you are talking things like that, this puppy can only go up to few volts, 3, 4, like 4 is also pushing it. Generally they are at 2.5. So be mindful, it's kind of low voltage. So what are the benefit of this sort of thing? Now let's say you replaced your car battery with supercapacitors, and you can buy them, like right now you can just go and buy them. The benefit of it is that they charge almost instantaneously. So when the inrush current happens, when you're like basically starter behaves like an alternator and it starts to charge the system, it's fully charged in few seconds. It's like done, charged, absorbed, done, no problem. Now that itself may be a big deal for not a big deal for car battery, but imagine that used for your let's say electric car. Imagine charging your electric car in flat out few seconds, flat out. You just connect the system and boom, it's charged, done, go. So that is a very crucial aspect. Then comes to the fact that battery, no matter what you do, you can only push, like I told you, like practically we only achieve 3 to 6,000. 10,000 is like mathematical. This puppy practically achieves 1 million. So there is no comparison in lifespan. Like your normal car, electric car could easily last 30 years. The motor itself is very simple. If specifically it's used what we call induction motor, it's gonna last for decades, and electronics you can replace it, but battery itself will only last for 10 years, 15 years at max. So but capacitor could last upwards of 30 years. Well built one. Now be mindful, supercapacitor by their nature is DC. As I already showed you in the last slide, that there are capacitors that is used in AC line for power factor correction. Those are different from this. You cannot use supercapacitor on AC system, it's only DC. Now to give you a mathematical context, how much energy, like if you are familiar with the joule calculations, how much joule a capacitor has, just multiply that with 100, you will get the capacity of these puppies. Supercapacitors are kind of very powerful. So if this is so amazing, is there any consequence to this? Yes, obviously. Now first consequence is low voltage. That simply means if you want to build a practical battery bank, you have to use a lot of them. Now the more you have, the more problems you will end up getting. It's a simple, people don't want to have like 600 cells, 800 cells, 900 cells in their car. It's just problematic to deal with. Like nothing, physics is not telling you can't do that. You can do that with a million cells, but you want to simplify the operation. That is a big problem. Now on top of that, this graph should give you a very clear idea what's going on. Now on this end we have power density, basically size of the battery. On this end we have what we call power density, as in terms of how much capacity. Like this is density and this is capacity. So you can easily see we have lead acid, very low. Then we have nickel cadmium battery, that is generally your rechargeable battery, and on top of that we have lithium ion. Now supercapacitor does not have the capacity in terms of basically density wise of lithium ion. What does that mean? Simply means if you are making a battery that has to fit in a specific place, as in 1 liter, let's say that volume is 1 liter. In 1 liter you cannot pack too much energy using supercapacitor. However, if you have weight limit, as in like let's say 50 kilo, that is your limit. Not a size, it could be of any size, but weight is limited. Supercapacitor generally has more, sometimes almost same as lithium ion, other times even more. So that's why it's a bit offset. Capacitors are a bit offset. Now that itself may be an issue for a car, but not for a truck or a bus. So why not people use it everywhere? Well, it also has what biggest hurdle of the system is high self discharge. What does that mean? Think of it this way: if you charge a battery, no matter what it is, be it lead acid, be it nickel cadmium, be it lithium ion, it discharges over time. Now it discharges over time. This discharges instantaneous the moment you disconnect it, because no chemical changes have taken place. It's not permanent, it is gonna deplete over time. Now that depletion is happening in every battery, every system there is, but those will deplete over, let's say, a month to a year. These will deplete in days. So that is very crucial. So if you actually want to use them, you have to have a rechargeable battery that's just there to slow down the self discharge rate. So that these three things combines does a kind of hurdle progress. So what we can expect in the future? Now think of it this way: it is the best add-on there is. Now you can add it on to your normal diesel truck. Now you're like, wait, what's it gonna do in diesel truck? You can install what we call active kinetic energy recovery system. Basically it's generally used in F1. Nowadays it's being used more and more in commercial applications also, where when you apply brakes, it does what we call regenerative braking, and it stores the energy that you're gonna waste. Instead of friction, it's storing that energy electrically. Now if you dump that kind of energy in a battery, no problem, but batteries are very, very, very heavy. So when you're talking about the battery weight itself, that is gonna penalize your payload capacity. So you don't want very heavy thing. However, capacitor is light, and not to mention, because batteries have cycle limitation, you have to change battery upwards of 2 to 3 days, because every time you are applying brake, you are changing the cycle. For this reason, using capacitors are preferred, and capacitors have a lot of capacity in terms of amps. How many amp you can dump into a capacitor, there is no comparison. Like, there are capacitors that can absorb upwards of 1 megawatt pulse. So be mindful, like if you apply brake and it dumps a lot of energy, you don't need to condition it. A capacitor can directly absorb it. Condition applied is a normal temperature. It's not like you put a capacitor at 100 degrees Celsius, it's not going to absorb that energy. It's just that within operational parameter, you can build a capacitor bank that can absorb a lot of power. Now what does that translate for our truck driver? Translates into better mileage, simply because every time it's applying brake, it's recovering some energy. That energy is being dumped back into the system when you are accelerating, meaning you are your engine usage is going down little by little, because from getting a heavy thing moving takes a lot of energy. Like maintaining the inertia is not that difficult, but starting that inertia, that takes time and energy. That energy is coming from capacitor that you would have wasted from braking anyway. So it kind of they're quoting upwards of 30% better fuel economy, but let's say practically you will, in real life, you will save 15% on your fuel balance. Then add on terms of life. This is very prominent in electric cars, and soon in next 3 to 5 years you will start seeing them in every car. Basically, every time you are applying regenerative braking, I told you don't want to waste cycle on your battery. The regenerative braking energy will directly go into capacitor, and capacitor will apply that peak voltage, peak amperage during acceleration. Benefit of that, because that peak, that's capacitor's home yard. Capacitor can handle peaks very well, but batteries cannot. So either you build a battery that is very big so it can handle the peak, or you have to have active cooling, or not to mention it will degrade the battery. So you will, that spike that happens whenever you are drive the accelerator, if capacitor is taking care of that, your battery will be safe. So even though you are adding weight to your battery banks, your battery bank will last longer, and not to mention you will get better range, simply because that energy cycle is happening much more efficiently. So it's a very good for electric cars. Then we come to the stability. Now, as I mentioned, that capacitors are already used in power grid in, to balance power factors, but as I already told you, you can only use it in DC. They do provide a very, very capable energy storage for millisecond shocks. So basically, every time a system changes, like let's say you're going from one power plant to another power plant, there will be a shock. Every time, like let's say some big industry starts their big engines or whatever they have, there will be a shock. Now these spikes are millisecond spike. The reason why you don't feel these sort of spikes in your day-to-day life is simply because when these sort of spike goes to the generator that is spinning in the coal power plant or hydropower plant, there is a lot of mass connected to the system. Like that steam turbine that is spinning, that is 500 tons, 2000 ton kind of turbine. So inertia is keeping handling that spike. Now when you have solar, where the spike goes to, in that place, these sort of things system can help us stabilize the grid. So it's kind of very useful. Now, can it replace battery? That's the final question. Can it replace battery? Yes, China already did this. Now, if you have seen my last episode about trolley buses, you must have realized that electric buses, while practical, the problem is they are very heavy and they waste a lot of energy just moving themselves. Basically 3 to 4 ton is the battery weight, so you are wasting a lot of energy. Now, capacitors, even though they are lightweight, what China did is like they removed the battery size. They removed battery to only to have enough for auxiliary power unit, and I did say the capacitors leak power, so to make sure they keep topping off the capacitors, and capacitor is the main power source. Now the capacitor will only provide enough power for 10 kilometers. They have bus stop every 5 kilometers. Now what they're gonna do when the power runs out, they have this sort of overhead power collection system. Benefit, because capacitor can charge in few seconds. Every time the bus driver stops and connects the pantograph, it already charges the system. So every bus stop, let's say it's 5 kilometer away, they're gonna charge, and since capacitors have a 1 million cycle lifespan, this is gonna run very long, and it's already been successful. That's how they are doing it. Like, instead of having battery, because battery cannot absorb charge at that rate, and not to mention it's big, heavy, bulky, and not long lasting, this provided a very good bridge solution. If we ever figured out a very good battery system, we will not need this. But at this time, the way things are going, supercapacitor may reach there before lithium ion is pushed any further. Because be mindful, lithium has, let's say, on a physics and chemistry level, this much power. We are already here. We can't really push it that further. So whenever you hear new technology, those technology are for safety mainly. Second, generally to improve the recharge speed, which again, the best case scenario, you still can't compete with this. And to increase the lifespan, things of that nature. So safety, rechargeability, and lifespan, these three things are where the money is being spent. But not like, you can't expect future's battery to have 50 times more power. It's not gonna happen, because now of course new chemistry comes along, something new comes along, maybe, but lithium is not gonna go up there. So be mindful, we're gonna see a lot of supercapacitor implemented in our near future. Now I hope you like this presentation, and if so, please like it. If you didn't, don't worry about it, you can dislike it. I would urge you to leave a comment. Please subscribe, press the bell icon if you're free, and as always, thanks for watching.